Hi everyone. My name is Bo Pan. Today I'll be talking about the architecture of the virtual machines by the James E. Smith and Ravi Nair. So here's the agenda today. We'll be talking about the abstract of the paper, what is the virtualization, the architect interface, the types of virtual machines, why is virtualization important in distributed system, and why does the paper resonate with me. So the abstract of this paper, the author mentioned the computer system have evolved and are still evolving due to their design principles. They are designed following a hierarchical structure with well-defined interfaces that separate the different level of abstraction provided by each hierarchical layer. That is good because that facilitates subsystem development with the well-defined interfaces. Also, they hide lower level implementation details, therefore reducing the complexity of the design process. However, the author points out that the limitation from well-defined interfaces is that the component designed to work with one specific interface will not work with those designed for another interface. And that is where the virtualization comes in. It is a form of abstraction. It's the process of creating a simulated or virtual computing environment that emulates the hardware or software resources. The virtual environment can include virtual machines, virtual storage, network, and virtual application. Today we'll be talking about the virtual machines. So you can kind of see the virtualization is defined by the author as the mapping of the system. So each virtual disk is get mapped to a real physical disk on the machine. Before we talk about virtual machines, we need to talk about the interface. So the interface defines the boundary and interaction between the virtualized environment and the underlying physical hardware. They're important because they ensure the compatibility, performance, and functionality. Here is the interface, different kind of interface. From a computer architecture point of view, we have different, on the right corner, you can see we have different components. We have the application, library, operating system, and hardware. And between different components, we have different interface. The first one is the infrastructure set architecture, the ISA, which sits between the operating system and hardware, also the library and hardware. The application binary interface, the ABI, sits between library and the operating system. The application programming interface, API, sits between the application and library. And interfaces are important because it defines the different types of virtual machines. So moving on, let's talk about virtual machines. But before we talk about virtual machine, we need to define what a machine is. From a computer architecture point of view, we can view a machine in one, a system point of view. So I'm the operating system. A machine to me is the whole hardware. So if we are virtualizing the whole hardware, will be the system virtual machines. On the other hand, from a process point of view, not only a machine to me is hardware, it is also an operating system. So if we are virtualizing the operating system and hardware together, that would be a process of virtual machines. So with that said and done, let's talk about process of virtual machines. Like we said, it virtualizes the hardware and also the operating system, sometimes even the library. The most well-known high process virtual machines would be the high-level language virtual machines. They were designed for full cross-platform compatibility, where the process level virtual machine is part of an overall high-level language application development environment that does not directly correspond to any platform. Examples would be Java virtual machines and also the Microsoft Common Language Infrastructure, the .NET framework. If you have ever coded Java, you know that Java does not compile the code directly into your machine code. Instead, Java compiler will compile the code into the bytecode, which will get thrown in the Java virtual machines, and from there it get compiled into a native machine code for executions. So that's process virtual machines. For system virtual machines, there are two types: the classic system virtual machines, The approach is to place the virtual machine monitor on the bare hardware, and the virtual machine will fit on top. AKA, so the author didn't mention that, but I believe nowadays people call the virtual machine monitor a hypervisor. So this is called the bare metal hypervisor, also known as Type 1 hypervisor. Examples are VirtualWare ESXi and also the Microsoft Hyper-V. They are mostly used in the market, but it can be but it pick big company because they're fast. The second type is hosted virtual machines. Is an alternative system virtual machine implementation builds virtualizing software on top of the existing host operating system, resulting in the hosted virtual machines. So in the picture, you can kind of see um, there is operating system and there is the virtual machine sits between. And on top of that, we have the host operating system in here. So they are mostly used by the end users, like you and me. Example would be the Oracle VirtualBox. So a use case would be, say you're running a Windows machine and you wanna, for some reason, use a Linux machine, then you can go ahead and download Oracle VirtualBox and also the Linux distro image file. From there, you can file up a Linux virtual machine with the current machine that you're having. I think it's also worth mentioning that the author also mentioned different types of virtual machines, but with the given time we have, I only pick three of them because I think they are the most relevant to us. Um, so why is virtualization important? Well, first, because the resource abstraction. Virtualization abstract the physical hardware and provide a isolated virtual environment, which allows the distributed system to allocate resources, the CPU, memory, and storage dynamically and independently to different components or services. Second, scalability and elasticity. So distributed system, as we know, very often need to scale up or down dynamically to handle variable workload, right? So virtualization enables that elastic scalability, allowing resources to be scaled up or down quickly and by adding or removing the virtual machines. The third reason, and also I think the most important reason, is the security and isolation. So security is a major concern in distributed system, especially when multiple nodes or applications are sharing the same infrastructure. Virtualization enhances security by providing isolation between different virtual machines. So when one node is down or get infected by virus, you don't want other nodes get infected as well. And the virtualization provide that. Um, Lastly, improve the resource utilization. Distributed system typically span multiple server or data centers. Virtualization optimizes the resource usage by aligning multiple virtual machines to share the same physical infrastructure. So if you want a new node or new virtual machine, you don't have to go out and rent the whole rack of server, right? So in fact, the cloud service actually handle that for you. So one server can run different virtual machines, and that can drive down the cost. The importance of this paper. So this paper was cited for 325 times. It also laid down a very solid foundation of the definition of virtual machines. So this paper resonated with me because first, the role it plays in distributed system is very crucial, and also I use virtual machine personally. I'm very into cybersecurity, and one of the important skill is to learn the Kali Linux. I don't have money to buy a laptop, so what I can do is I can install the Oracle VirtualBox on my Windows machine, and from there I have a brand new Linux machine. Also, if my uh, guest system get compromised, my host system will still be safe. So here's the paper that I chose. Thanks for listening. If you're interested, feel free to go ahead and read this paper. And yeah, hopefully I can answer your questions.